I want to go over the volume of distribution at steady state for local anesthetics, which is definitely not something you need to know, but it is very interesting, and we talked about volume of distribution at steady state in a different video, and I think this is just a really good example where the numbers work out nicely. So we'll just kind of jolt your memory on this. Or you can skip it and watch the next video where we talk more about toxicity. But remember, your max dose for lidocaine is 4.5 milligrams per kilogram, 4 or 5. And then your plasma concentration where you start to see toxicity is more than 5 micrograms per mil. And for bupivacaine, your max dose is 2.5 milligrams per kilogram. And for this, you start to see toxicity at plasma concentrations above 3 micrograms per mil. So I thought it was suspicious that these numbers were so similar to the plasma toxic doses. And indeed, this does have to do with the volume of distribution at steady state for the drug. Lidocaine has a VDSS of 1.3 liters per kilogram, which is maybe not such a easy number to work with. But bupivacaine's volume of distribution at steady state is 1 liter per kilogram, which is just so nice to do the math for. Remember, with volume of distribution at steady state, you're basically saying, what volume does it look like I put my drug into? So by saying bupivacaine has a volume of distribution at steady state of 1 liters per kilogram, you're saying that for a 100 kilogram person, it looks like you've put that drug into 100 liters. So where is that drug hiding? Probably blood, tissue, protein binding, etc. But the combination of all those things for a 100 kilogram person makes it look like the drug is hiding in 100 liters. So we take 2.5 milligrams per kilogram as our max dose, and let's give that to the person. And again, this guy is 100 kilograms. So multiply by 100 kilograms gives us a 250 milligram dose that we'll give to this person. So it'll look like we have 250 milligrams in 100 liters. If we crunch these numbers, we end up with 2.5 milligrams per liter, which is 2.5 micrograms per mil, which is just below this toxic dose. So we give this person basically the max dose of bupivacaine that's allowed, and because of the volume of distribution of that drug, his resulting plasma concentration is going to be just below what we consider to be the toxic dose. Importantly, volume of distribution at steady state is very different than the volume of distribution initial. So just like in this example where we give a seemingly safe dose of lidocaine very rapidly into the intravascular space and we see toxicity, obviously the same thing would happen with this dose of bupivacaine here. If we give the 2.5 milligrams per kilogram intravascularly, we're going to see a very high peak with the volume of distribution initial of this drug, and then it would settle out as it reaches steady state. Also worth mentioning that these volume of distributions are as defined in a healthy person. So someone with hepatic or renal or cardiac dysfunction will have a different volume of distribution. And also, very importantly, drug clearance will be affected by all those things. So a maximum safe dose of bupivacaine is not the same for a healthy person as it is for someone with renal or hepatic dysfunction.